Audio. Okay, in today's lecture, we are discussing about again chapter 2, descriptive statistics. Last time we have discussed how to make frequency table for visualizing data after collection, how you can visualize your data in if you have a raw form data, which is in ungrouped form, or if it is in grouped form, that how you can make it. So you can make frequency tables for both of those group of data. If you have ungrouped data, that is easy to find. You can just count the values, that how many number of values it has in, just like the blood group data we discussed last time. And if you have a group data, then we always make classes. We make it into sections or groups, and we then we check that how many number of values occurred in each group. That is actually called frequency. So after frequency table, the most common the graph we use for visualizing for visualizing frequency tables is histograms. So we have discussed histograms and the number of other graphs we have seen for many groups of data, for categorical data and for also numerical data. So in today's lecture, we will discuss a little bit more about that how we can describe the data in a meaningful way. That means we are going to find the characteristics. And last time I have discussed, I think in the very first lecture, I discussed about sample and population. And throughout this course, we will discuss about sample and population, sample space. Most of the times we discussed about sample space because it is easy for us to predict something for a future outcomes to take it from samples. So if we are discussing about characteristics of a sample space, that means we are talking about statistic. Or if we are discussing about the characteristic of population, that means we are discussing about parameter. So statistic and statistics are both different words. Statistic means that you are talking about the characteristic or some mathematical tool or statistical tool you are finding for the sample space. And if you are discussing about the population, that is parameter. And statistics means that it is defined in a meaningful way in 5 different ways, that you have to collect data, you have to organize it, picturize it, and analyze it, and then you interpret it. That is called statistics. So this is the difference between statistic and statistics. So let's talk a little bit about what characteristics we can figure it out for a number of given data. It could be in raw form, it could be in group data. Raw form means it is in ungrouped form, and if it is you are making classes for those groups, those number of values that you have been given, that it means that we are discussing about group data. So there are 5 major characteristics that we will be discussing today. One is center of for the given data, that for most of the values are around to this value. That means what is the center of it. The second thing is we are talking about variation, that how the number of values in the given data are varying, how they have been spread out in the given chart or in a given data sheet. Or distribution, how we can visualize it, in how what kind of distribution we can see from the given data, and what are outliers. We will also figure it out with some examples, that what are outliers and changes over time. We will discuss it further. So the first thing is center. Center means we will talk about central tendency. So it means the data is given to you, and you need to find out what is the center of the given data. Center means the middle of the data set that you have been given. So there are 3 ways, or I'm adding one more way, which is just the defining way. So there are 3 major ways we can use to find the center of a given data set. So number one is very common, we all use in our practical life, finding the average. That is called mean in statistics. So mean means average arithmetic value. So for instance, if I have a number of students in the class, again, I'm talking about the age, that different age groups of people in my class. So if I want to find out that, okay, what is the average age for all of the students in this class? So what I will do, for instance, if I have 5 students, let's say I'm calling these 5 students X1, X2, X3, X4, and X5. And I'm writing their ages. So we are using variable for certain characteristics. So for X, it means we are talking about characteristics of um, of the object. So X means, here we are using X as age of the, in this example, we are talking about age. So X is a variable where we are writing the age values in it. So let's say first one student, let's say 18 years old, other student is 21 years old, and the other student is, let's say, 20 years old, and one student is 24 years old, and one student is maybe 25, or further. So if you will take its average, so average means we're talking about mean. So if you take the average, you will sum all of these values and divide it by number of values, number of students we have in this class. So it means if you are talking about mean for the age of the number of students in the class, so that means I'm talking about x1 plus x2 plus x3 plus x4 plus x5 divided by how many number of students are these? 5. So this will give you the mean or average value for age. So this is how you calculate. It will be around, like, because most of them are in 20, so it will be giving you value. If you will calculate it, you will find some 20 point something or 21. In 20s you will find the figure out. So that will tell you the average uh, age value for all the students in this class is around 20 point something, what you will figure out in this formula. So that is mean. So this is what I have defined mean here, that if we add all the values and divided by the number of values you added, that is mean. So throughout this course, we are talking about sample and population. So if we similarly, so in same case, if we are taking mean for the sample, that will be a sample mean. If we are taking mean for the population space, that is population mean. So this is the general formula we use. Mean is sum of this sigma sign we use for the sum. X is a variable, and I'm writing divided by number of values, but we are assigning symbols for these things with respect to sample space and with respect to population. If you are taking sample space or sample mean, so we are representing it with X bar, the little line on the top of X variable. This will give you mean of the sample space. So what is the formula for this thing? This is sum of X by small n. So small n means that number of values or number of samples, number of values we are having in a sample space. So for instance, in this example, for age groups, we have 5 number of students. So n is 5, small n is 5. And if we are talking about population mean, so this is representing by the little u sign, which is Greek letter. This is what we call it mu, mu. You can say this is, we call it, pronounce it with mu sign. So this is represented by sum of X divided by this. If we are taking the number of values for a population space, so we will representing it by capital N in this case. So sum of X divided by capital N, and we will write it as mu. So this is called population mean. So it's very important for you to know if in the question you have been asked for either the sample mean or the population mean, because the number of the sign values and also the number of L values will be changed according to the formula. The sample mean and population mean I have defined here. So these are the some symbols I have written for you in this case. This sum sign is the sigma sign is used for summation, sum of all the variables. Like in our example, x1, x2, x3, and xn. If you sum of all these values, that is with sum sign, you write it down. And small n is the number of items in a sample space. The capital N, we write it for the number of items in a population space. Population, mostly, generally, we take thousands of values in it for the population. Like if we take an example of like the age group or for the number of students in mid-Michigan college. So this is our population space. If I'm talking about the number of, what is the age group for the number of students in statistics class in Harrison campus. So that means we are taking the small sample space. So then N will be smaller N. So capital N for the mid-Michigan students. So you are taking the number of, whatever the number of students you are taking, that is capital N. So X is a variable. We use it for data values. Like in this case, age is the data value in our example. X bar on it is used for the sample mean, and the mu sign will be represented by population mean. You will call it, you will write it down mu. Whenever you write mu, that means population mean, and whenever you write X bar, that means sample mean throughout this course. So for example, this is one of the examples. For instance, I'm taking some fictional data. Let's say I am talking about the amount of dollars in car, generally how much we have. For instance, one car has $5.40. Another car has $1, one pence, and then 0.42, 42 cents. One car has 73 cents, one car has 48 cents, and another car has $1, 1 cent. So how many car we are taking? 1, 2, 3, 4, 5, 6. So number of values we are having. So N in our, because this is sample space, very small number of values I'm taking for the car. So N will be smaller N. So number of values is 6. And we are talking about sample data. So that means if I have to find out the mean, so we are talking about the sample mean, and sample mean will be written as X bar. So if you're writing it X bar, so what is the formula for this? Sum of all the values in the given data divided by number of values that have been given. So in this case, X is all of these values. So it means I'm writing it down 5.40 plus 1.10 plus 0.42 plus 0.73 plus 0.48 plus 1.10 divided by number of values, which is 6. Now I can find it out. What is the value? Could you figure it out? Let me see. Let's see what is the value we can find. So this is giving me 1.538. So, and 333, so on, right? So this is our sample mean for the given data number of values. So it means the mean value for the number of dollars in each car will be around 1.538. So it could be it means all the values will be around 1.538. It could be 2, it could be 1, it could be 3, something like this. So it will be around of it, but not way out of it. Like it cannot be like 300 or 400, because the mean is our 1.38. So this is how we find somehow center of the given data. Here, one thing is very important for you to know. In statistics, we always round the values. You always find some values and you see in your calculator, these are decimal places, 0.38 something. Like in this case, 0.53833 something, or so on. So this is very important. There is a rounding rule for it, which is a thumb rule, that you always get round the number to one decimal place more than what you have been given in your data. For instance, in this example, we have been given numbers are in 2 decimal places. So this is why whatever the answer we are having, we will round it to 3 decimal places. This is the general rule for us. The and another part of rounding value is very important, that for instance, here we are just asked for finding the mean of the sample space. Maybe later on you will be asked for something more specific characteristics. It could be anything, and for in that case you will use one value to another formula, another formula to another formula. So you will not round the values until you will be getting your answer in the end of your problem. Because what happens when you round the values in the very beginning, so you always adding some errors into it. You are using into another formula, then that error is being used in another variable, and if you use that variable to another variable, so you are adding all the errors in that till end. So this is why if you have been asked the way to find some characteristics or finding any value, so you will never round the value until you are going to end of your problem. So in the end, whatever the value you will get, then you will round the value to one decimal place more than the value you have been given in your data space. So this is how we will find. Okay, another way for finding the center of the data is the median. Median is actually called the middle of the data set. You have, most of the times you have heard, okay, when you find some, let's say you you find the house price in Michigan state. So we always find the median price for all the house values. We it's rarely we have been asked for the mean value for the given for the house values for the house price values in any given in any area you are going for. There is a reason behind it, and this thing we will be discussing in the end of it. So median is middle of the data set. So in this case, whatever the values you have been given, you will always use the rule that you will always make it in an order. So in an order means you either write all the values in an ascending order or the descending order. So the convention is whatever the values you have been given, you always write it in an ascending order, smaller to larger values. And once you order that values or order that given data sets, then you will see that you can have two cases. One case that you can have odd number of values, and another case you can have even number of values. If you have odd number of values, like in the previous example, we have number of values were 6. So it means even number of values were given in this sample data. So if you will, you might have odd number of values. So if you have odd number of values in the given data space, so that means the middle value, the median is always the middle number of the given data set. Or if it is even, then the median is the, you will find, because all the values are even, you cannot find the exactly the center of all those values. Like for instance, if you have 8 values, 4 data values are on right and 4 data values on your left, but there is no center for it. So in that case, what you will do, the middle two values you will take, and you will take its average. So it means you will find the mean of the two middle numbers if your data values are in even numbers. Here is an example. For instance, we have these number of values for the given data. Let's say we have, in the first case, we have 1, 3, 4, 5, 6, 7. We are going to find median for this data set. So first thing is it has to be in an order, but it is already in order. It is already in ascending order, 1, 3, 4, 5, 6, and 7. So you don't need to write it in an order. Second thing is you need to check whether it's even number of values or odd number of values. So in the given data set, we have even number of values because we have 1, 2, 3, 4, 5, 6 values. So in that case, the median is, the center will be these two middle numbers, 4 and 5. So you will take its average. So median is 4 plus 5 divided by 2. So the value is 4.5. This is your median. And in the next question, how many values you have been given in your data set? 8, 3, 5, 11, 13, 4, and 6. So number of values we have 7. It means here odd number of values. You will not write directly the middle value, because you have to check first whether it's in order or not. So in second example, the values are not in order. So you have to write it in an order, in an ascending order. So the first thing is what we will do, we will write it in order. The first step, write it in an order. So this is, let's start from the smaller value, which is 3, 4, 5, 6, 8, 11, and 13. So now it's in an order. Then step 2, you will find the median. So in this case, the number of values are odd. So it means 3 are on right and 3 are on your left. So the middle value is 6. So in this case, median is 6. So here, this is how we will find the median for the given data. Projector is off. Hold on.